Great webinar for you all today, Device Connectivity 101. We're going to talk through a lot of different topics. There's a lot of different causes, root causes to Wi-Fi connectivity. And we've got Jim Vada back with us today, CWNE 183, and our Chief Wireless Officer. And with us, as usual, is Heather Dremel, our Digital Marketing Manager. So, Jim, I'm going to pass the controls over to you as quickly as I can, and we'll get things going.
Sounds good.
I've got your screen.
Right. Yep, looks good. So real quick about me, I'm, like Don said, I'm the Chief Wireless Officer here at 7 Signal. I'm also a CWNE. I think a lot of you, yeah, go ahead.
No, I'm sorry, I was looking at the wrong screen. You're good to go, I apologize.
Yep. I'm also CCNP Enterprise, working on renewing that right now. And a little bit about me on that slide, but wireless network engineer, that's my focus. And so today we're going to talk about, some of the more recent Wi-Fi connectivity issues, things that pop up in the enterprise, things that pop up in work from home. And, the biggest one that we come across is definitely roaming. Roaming's a big problem in Wi-Fi. It's really hard. And, many clients just don't work very well when it comes to roaming, particularly in the enterprise. And there's a few reasons for that. First, we're using a lot of lower end consumer and IoT devices in the enterprise that don't have roaming in mind when they're designed. So these are often designed for a single AP home or apartment where roaming performance just isn't a priority. Or they're not designed with a vision that they'll be mobile while they're actively in use on a enterprise Wi-Fi network. And unfortunately, we're flooded with a lot of devices like this in the enterprise. That's because, the people in the business expect the things they use at home, that they'll be able to use those same things at work. And sometimes purchasing decisions are made without, IT's involvement or evaluation of the devices that are coming onto the network to see if they'll work very well. And these roaming performance and capabilities, it's usually not something that device manufacturers list in the features and spec sheets of these devices. Compounding the problem, there's a visibility issue. It's hard to tell if the clients connected to our enterprise networks and certainly work from home networks are roaming well, and what their experience is. And a newer thing that we've seen growing in popularity is with mesh networks at home, where actually you do have multi-AP networks. You do to some degree need effective roaming. And with so many people working from home now, that's become a bigger issue for the enterprise to tackle. So I want to take a few minutes and talk about what Wi-Fi roaming is, and when it's, describe some examples of what it looks like when it works well, and also, what happens all too often when it doesn't work very well. But you've got a client, in this case that smartphone, moving through the physical environment. And as it moves, it gets further away from the access point it's connected to and closer to another AP, and it seamlessly reassociates or reconnects to that next AP as it moves. And it continues this process as it's physically moving. And that's what Wi-Fi roaming is. And so it's important to understand that that client, that smartphone, is in charge of making those roaming decisions. All the APs are beaconing. They're advertising the presence. Hey, I'm over here. Hey, I'm over here. The client learns about the presence of all those access points, but then the client has to decide which ones it's going to connect to. And that's actually a root of the problem with Wi-Fi roaming performance. Another way to think about roaming, and if we want to put it in terms of the OSI model, is that we're at layer 2, we're just transitioning from BSSID to BSSID. We're forming a new association to that next AP. And layer 3 and above is unaware of that and is unaffected by it. If we're roaming well, our packet loss is very low, our latency and other layer 3 measurements are acceptable. And so layer 3 and above is unaffected. Our IP address doesn't change, our application performance is good, everything looks good. But all too often, we have bad roaming performance. And just to illustrate what that looks like, you've got your smartphone, could be any mobile device, but we're going to talk about a smartphone in this example. It's got that first association to its nearest AP, and then as it starts moving, it just holds on to that association. It's closer to other APs, but you know what? It's just not roaming. It's sticking to that first AP it connected to. That's where the term sticky client comes from. The other APs are there, they're ready to be connected to. They're providing much better signal strength and better performance if the client would connect to them, but it's stuck on that first AP. And in the worst case scenario with a sticky client, it will just never let go until it's completely incapable of passing any traffic at all. Its connection quality is so poor, can't get any packets across the interface. Eventually some timeout occurs and it just restarts its networking stack and reconnects to another AP. That's kind of the worst case scenario, but it's not an uncommon scenario. Some devices really just don't roam at all. They kind of lose their connection and create a new one. And that's terrible, right? If we've got a device that's in use while it's mobile, which is more and more common in enterprise use cases, particularly in hospitals and manufacturing, and now in all wireless offices, we see that more and more. And so, Wi-Fi roaming is something that's really challenging from a connectivity perspective. Additionally, in the last year or more, enterprises have been dealing with connectivity issues in home Wi-Fi networks. And, there's really difficult challenges with that. First, consumer networking equipment is very low end. It's a race to the bottom in terms of making home networking equipment as cheap as possible, and that's in order to get there, they have to sacrifice on components and quality and software testing. Go down the list. Everything suffers from that. We're also using residential internet connections where we don't have any QoS, and our traffic isn't. We don't have an SLA with that internet service provider. Like a business WAN connection will come with some guarantees about performance, and if they're not met, you might get paid from that WAN provider because they were unable to meet the contract you signed with them. I don't think Comcast or Spectrum sends anybody a check in the mail if your home internet isn't, performing perfectly. Wouldn't that be nice? There's also, no network design in homes, right? Most home networks are not put together by network engineers, certainly not wireless engineers. So everything just kind of gets plugged in, like shoved into a corner. And if I can load a web page after I connect to the SSID the router shows, then we're good. So, suboptimal designs for sure. No, or very limited QoS sometimes. You might have QoS over the air if you're lucky with WMM, but you never really know. And huge challenge, just like the roaming challenge in the enterprise, is a lack of visibility. So we have a lot of enterprise visibility tools we can use on our managed networks. We can look at the infrastructure and look at all the telemetry coming off that. We might have site surveys that can help us with things. We might have sensors and software agents like we have at 7Signal to give extra visibility. But as soon as that device goes home, now we're on a WAN connection, an internet connection that's unmonitored, using a home network that's unmonitored, and a device with no monitoring on it as well. So you need visibility. It's a big visibility problem to sort these things out, and that's where 7Signal comes in, particularly Mobileye. So Mobileye is an agent that runs directly on the device. You can follow it home, follow it to Starbucks, follow it around the enterprise network. And one of the things we track and measure is roaming performance. And shortly here, we'll have a look at exactly how we do that and what it looks like. We run on Windows, macOS, Android, and Linux, including some thin clients. And we're network neutral. We're certainly AP vendor neutral. But we'll work with your enterprise Wi-Fi network, work with consumer Wi-Fi networks. Go on down the list. If it speaks 802.11, it works just fine with us. And I should also mention that Mobileye is very easy to deploy in bulk, including remotely. And the data coming from those agents goes to the cloud, where it makes it easy for you to view the performance even for clients that are off the network. Okay, so why don't we transition into a demo? Here we go. All right, so this is a look at our Mobileye dashboard, just showing a single device and all the data we've collected from it and analysis we've done on it. This is a work from home user in our demo environment, and I can go back in time and look at the channel scan results directly from his laptop. This is really cool because now I can see the whole RF environment that he's operating in. If I want to make a suggestion about, hey, maybe make your SSID 5 gigahertz only, because 5 gigahertz is nice and clean and 2.4 is a mess with this 40 megahertz channel width and use and all the CCI, it's easy to do that. But I can also, besides just looking through all the data and making my own inferences about network performance and what's going on, we do automated analysis and generate problems for you. So you can see, using these timelines on the left, what's good and what's bad with this client. So here's the roaming analysis that we do, and it's actually quite simple. Once you have the data that's on the client, from the client perspective, determining if roaming problems exist is quite easy. It's really hard to do it from the infrastructure side. But if you know the signal strength on the client side and its channel scan results, makes it quite clear when roaming issues are occurring. So if we hover over this first dot, we can see, pretty classic roaming problem. Signal strength at negative 72 dBm. That's a little, borderline, but maybe that's lower than the threshold that we want before roaming occurs. And at the same time, there's a neighboring AP at minus 51 dBm. So big delta in signal strength there. And we'd prefer that during this time period, this device would have roamed to this other AP with better signal strength. We can also see when, coverage issues are going on, and we can drill into that and see where, our signal strength is neg 74, but actually, there isn't a better neighbor, and the best neighbor is just 2 dB louder. So, we're down below the threshold we want. This is a user we need to talk through, where's the placement of your router? Is it shoved behind a refrigerator or something like that? Are you 3 stories away from it or something like that? And not just, hey, get closer to your router, going through a script like you get with the cable company, but actually having some real data here that tells you exactly, if we're within our requirements or not. So really, really helpful there. We also do throughput measurements. So we can drill in and see what kind of throughput we can get from that work from home environment. So in this case, for this time period, we had really terrible download throughput, 0.5 megabit per second. So, I mean, this webinar would be going off the rails if I only had 0.5 megabit per second of throughput right now. And whatever business processes this, this user might be engaged in, probably not at 4 or 5 in the morning, but if this happened during the business hours, this would be really impacting what they're trying to accomplish. But it also tells you something that about the nature of the issue, right? So if the help desk gets called, the end user might say, Citrix is slow, or the VPN is slow, or they want to tell you something that you're responsible for is wrong. Of course, because otherwise you're not going to help them. If they tell you their internet connection is wrong, you tell them to call Comcast and get that sorted out with them. But this gives you the tool to sort that out and discover, what the most likely root cause is and where to evaluate that. We can even take it a step further too with the, using the external IP address and doing a whois lookup, and we can say, hey, this is Roadrunner, this is a Spectrum internet connection, and you need to call them because it looks like maybe your Wi-Fi network's okay, maybe everything else is okay, you just have a really slow internet connection. So really helpful there. The other active tests that we run are helpful too in establishing that we can access the applications that we need. We can run a ping test from wherever the client is against the specific applications that we need to use, and even do web download tests if they're web apps to see how fast those are running and the latency involved. Really helpful there. And something that's a little bit newer is the ability to do VoIP tests in Windows. So now we can measure the expected VoIP quality displayed in a MOS score from your Windows and macOS clients as well. So, VoIP, very, very critical to enterprise applications and the Microsoft Teams and Zooms of the world. And now we can, and there's always a question about, residential internet connections and networks. Are they, working well enough to sustain that? And this helps answer that question. So really, really helpful there. This is all sort of the reactive troubleshooting that we can do in Mobileye. Part of that too is looking exactly at the wireless adapter and driver the machine's running. This has a big impact on roaming. So I might want to go investigate and see if Intel's got a new driver version for this adapter. But I can also run some reports and see who's had the most issues proactively. I can go and discover who's got the most roaming issues. It was the machine we were just looking at. But also, who's suffering from the most congestion on their network, and who's got the most code channel interference that they're dealing with. Maybe I can send them some advice about changing the channel their AP is operating on, or like I mentioned before, going to 5 gigahertz only. So there's a lot there, and particularly around roaming and work from home, and the type of problems that are really centered around clients. That's where Mobileye can have a huge help. Okay, I think with that, Donna and Heather, we have a little extra time for Q&A.
Sounds good. Thanks, Jim. We got a lot of questions and things in here. I'll give folks some more time, and I'll get caught up on my shout outs here to ask some more questions. I got a kick out of Johannes from Finland. He said he's dialing in from his sauna today. We appreciate you joining.
Very lucky.
Exactly.
I hope you have a weather-resistant phone there.
Right. Let's see. Gregory from Lexington, Dan in Rochester. Paka had a note around Zebra and Honeywell devices and how keeping them connected is very important. He's absolutely correct.
Yeah, that's right. Our Android agent gets deployed on those quite frequently, so definitely something we're familiar with.
No doubt. And there's a couple questions in here around the same thing, so I'll paraphrase for everyone, and that is around help desk teams using this product to respond to Wi-Fi questions and not the need to escalate to a Wi-Fi engineer. Can you talk to that a little bit?
Yeah, that's right. That's something that we've added, in the last year. Oh, good. I am sharing again. So this is something that we've, one of the use cases is, help desk, and how can we make this friendly for help desk people that, they're capable of coming in here, searching for a machine like this one. We bring it up to see the problems they've experienced. And let's see, bring that back up. And okay, we can see from the timeline that the period that someone called in from, they were having roaming issues. But okay, how can we take that a step further? That's where our troubleshooting guide comes in. So over here on the right, there's this really handy troubleshooting guide. It's really designed for that first level of customer interaction, with some tips just about what the nature of the problem is. If roaming is something your help desk user is unfamiliar with, we'll describe it, and then suggest some fixes that that end user and the help desk engineer can work on that might help things out. So in a lot of platforms, the quick and dirty way to fix that immediately is just turn the Wi-Fi connection or the Wi-Fi interface off and back on. And then in Windows, like I mentioned, we can go in and look at doing driver updates as well. So tips for each of these that, in terms that can help that help desk make sense of what they're looking at.
Thank you, Jim. Question from Joel here, specific to whether or not we can install Mobileye on Zebra PDTs, the handheld computers, Samsung Android tablets used in distribution centers. I'll take that one. The short answer is yes. Any Windows, Mac, Android, Linux, iGel device we can install and run on. Jim, do you want to talk to how the deployment is? I know you touched on it briefly on the deck. You want to just reiterate that a little bit? He's looking for a centralized solution, sounds like.
Yeah. Deployment in Android is done through MDM. So whatever MDM you use to install other apps, you can install Mobileye that way as well. You can push it from the Google Play Store, or if you don't run Google Play, you can use an APK. We'll distribute to you as well. We can also do the configuration of the app remotely as well, so it's pretty enterprise friendly.
Thanks, Jim. Alan wants to know if Mobileye is only SaaS or can it be delivered on-prem. I can handle that one. So Mobileye is delivered SaaS only at this point. We are GDPR compliant, if that's your question. Having it installed in the cloud and the UK and EU is no issue for us. We have hosting centers all over the world. Hope that answers your question, Alan. Had some questions around iOS as well. Our visibility, as you expect, on the iPhone is limited, just like every other application developer out there. We do have some visibility. We can run ping tests and throughput and that sort of stuff, but we don't position it for sale in our marketplace, just because of the inability to pull data from the iPhone. Let's see. Well, you want to touch on this one a little bit, Jim. It's around cellular, but are there any plans to roll out 7-signal to look at cellular connectivity with the prevalence of 5G networks? But if you have an answer for that.
Sure. Yeah. No plans, but it's something we're paying attention to. Put it that way.
Yeah. Let's see. One more question here, unless I can scroll to another quickly, but let's see. Prashankt says, is this 11R roaming analysis or 11 kV?
Oh, good question. So our roaming analysis occurs kind of independently of the roaming features that the clients and APs might be using. So, one good use case for it is to test the effectiveness of those features. You can do before and after testing with, enabling 802.11r fast transition and see what effect it's made. And same thing with 802.11k. And that's particularly useful for 802.11v, which in some cases can make client roaming for some clients not so great if the interaction between the infrastructure's ideas about when the client should roam and how the client interprets that, sometimes those don't get along so well when you have 802.11v enabled. So Mobileye is a great way to get visibility into that and see, the before and after changes of enabling each of those or a combination of them.
And Pekka had a follow-up question just around how we're reporting. Is it a big data offering, or is it just as you displayed through the report section? So
yeah, it's all in our dashboard today. And you know, integrations into other systems is on our near-term roadmap.
All right, that's all the questions I can find and quickly see in the Q&A panel there. So thank you all very much for joining us today. We're finishing up pretty much on time as usual. Jim, great job today. Heather, thanks for the support in the Q&A areas. We will see you all next Wednesday.